Alright, so we're going to do a quick Physics 2 problem where you have 2 point charges. One has a minus, it's supposed to be in blue, minus 8 microcoulomb charge. And the other has a minus 3 microcoulomb charge. And they're separated by a distance of 2 meters. Now, the question is, first off, sorry, that's my puppy. Are the charges attracting or are they repelling each other? That's the first thing we want to ask. And then we want to know what the actual force is. So, first off, are these attractive or repulsive? The fact that the signs are the same means that they're going to repel each other. They want to get away from each other. If the charges were different, then they would attract each other. But since they're both negative, they both attract each other. Now, what we're going to use is Coulomb's law, which says the force is going to be K, which is a constant, the magnitude of Q1 times Q2 over the distance between them squared. Now, we'll break this down a little bit. K is just a constant. You don't really have to worry about that. Some professors will have you have different numbers for it, but it's about 9 times 10 to the 9th newtons times meters squared, and then we all divide it by our coulomb squared. Your professor might have it as like 8.9 or whatever, but we're going to keep it at about 9. Okay, so that's our constant. Q1 and Q2 are your charges. Now, the charges have to be in coulombs. 1 coulomb's a big charge, so you're usually going to have to work with microcoulombs or nanocoulombs. Anything, you're probably not going to be working in microcoulombs. So you're going to want to convert this. So 8 microcoulombs, that's equivalent to negative 8 times 10 to the negative 6 coulombs. So know your prefixes. And we can say the same thing for negative 3 microcoulombs. And then R is just the distance between them in meters. So now we have all this. The force is equal to 9 times 10 to the 9th. I'm going to leave the units out just to make it a little less messy. Times the absolute value of negative 8 times 10 to the negative 6 times negative 3 times 10 to the negative 6. That was my fitness thing. All over the distance between them squared. 2 squared, that's just 4. And if you were to plug this in your calculator, you should get about 0.054 newtons. So this is the force that's pushing these 2 charges away. That's this force. That's also this force. Now it changes over time because your distance will change over time, so the actual force itself will change. But that's how you do this problem. Just a basic intro to Coulomb's law. Coulomb's law is this. So hopefully that helps out at least a little bit.